Hi everyone. Today we'll learn how to apply L'Hopital's rule when we are dealing with indeterminate products and indeterminate differences. Let's start by computing the limit of ln of x divided by x as x goes to infinity. If you would like to try this exercise on your own first, stop the video now. You can download these notes using the link in the video description. This limit is of the form: in the denominator, I get infinity. In the numerator, as x goes to infinity, ln of x goes to infinity. ln of x looks like the following: as x goes to infinity, the y values also go to infinity. This means this limit is of the form infinity divided by infinity. To compute it, I can apply L'Hopital's rule, and I get the limit as x goes to infinity of the derivative of the numerator is 1 over x. The derivative of x is 1. This is of the form 1 over x divided by 1, which gives me the limit as x goes to infinity of 1 over x. As x goes to infinity, the fraction goes to 0. This limit is 0. I was allowed to use L'Hopital's rule here because the limit was of the form infinity divided by infinity. What should we do if the limit is not of that form? Take a look at the next example. We have the limit as x goes to 0 from the right side of x ln of x. As x goes to 0 from the right side, x gets closer and closer to 0. What happens to ln of x? ln of x looks like the following. As x's get closer and closer to 0 from the right, the y values get smaller and smaller. They tend toward negative infinity. This means that this limit is of the form 0 times negative infinity. This is an indeterminate product. I am not allowed to use L'Hopital's rule here because L'Hopital's rule is only for the limits of the form 0 divided by 0 or infinity divided by infinity. To apply L'Hopital's rule, I need to rewrite this multiplication as division. For example, 3 times 5 can be rewritten as division by writing it as 5 divided by 1 over 3. Because note that 5 divided by 1 over 3 is the same thing as 5 times 3. Dividing by 1/3 is the same thing as multiplying by the reciprocal, multiplying by 3. Similarly, 4 times 5 is the same thing as 5 divided by 1 over 4. I will apply this rule here, and I will get the limit as x goes to 0 from the right side of ln of x divided by 1 over x. Instead of multiplying by x, I divide by 1 over x. I do that because now the limit is of the desired form. ln of x goes to negative infinity. 1 over x goes to infinity as x gets closer and closer to 0 from the right side. As this gets closer to 0 from the right, this expression gets closer and closer to infinity. This limit is of the form negative infinity divided by infinity. This is one of the forms allowed by L'Hopital's rule. So I am now going to apply L'Hopital's rule. And I get the limit as x goes to 0 from the right side. The derivative of ln of x is 1 over x. The derivative of 1 over x is negative 1 over x squared. Let's compute this limit by first simplifying this expression. I get the limit as x goes to 0 from the right side of 1 over x times the reciprocal of this expression. Dividing by a fraction is the same thing as multiplying by its reciprocal. So I will multiply it by negative x squared. That's a reciprocal of negative 1 over x squared. I can simplify this a bit. This gives me the limit as x goes to 0 from the right side. One of those x's here cancels with one of those x's here, and that is simply the limit of negative x. As x goes to 0, this expression goes to 0, which means that this limit is 0. The conclusion here is, if the limit is not of the form 0 divided by 0 or infinity divided by infinity, you can try to rewrite it so that it is. Let's see if we can apply this technique to two limits. If you would like to try this on your own, stop the video now. I must find the limit as x goes to infinity of this expression. As x goes to infinity, x squared goes to infinity. As x goes to infinity, this x squared goes to infinity, which means 1 over x gets closer and closer to 0. And tangent of 0 is 0. This is of the form infinity times 0, an indeterminate product. I cannot use L'Hopital's rule. First, I must rewrite this expression in the form of division. I write it as the limit as x goes to infinity of tangent of 1 over x squared divided by the reciprocal of x squared, which is 1 over x squared. What is this limit exactly? As x goes to infinity, the denominator goes to 0. The numerator, this gets closer and closer to 0. Tangent of 0 is 0. This is of the form 0 divided by 0. I am allowed to use L'Hopital's rule. When I do so, I take the derivatives in the numerator and in the denominator. Let's start with the denominator. The derivative of 1 over x squared is negative 2 over x to the third power. And that is because 1 over x squared is the same thing as x to the negative second power. When I take the derivative, negative 2 comes down and turns into negative 3. So that is the same thing as negative 2 times 1 over x to the third power, which is exactly what I wrote here. To take the derivative of tangent of 1 over x squared, I apply the chain rule. The derivative of 1 over x squared is negative 2 over x to the third power. The derivative of tangent is secant squared. So I multiply this by secant squared of 1 over x squared. Few things will cancel here. I see that I have negative 2 over x to the third power in the numerator and in the denominator. Those things cancel, and I am left with the limit as x goes to infinity of secant squared of 1 over x squared. How much is that limit? As x goes to infinity, 1 over x squared gets closer and closer to 0. So I get here secant squared of 0. What is secant of 0? Secant of 0 is the same thing as 1 over cosine of 0. Cosine of 0 is 1, which means 1 divided by 1 is 1. 1 squared is 1. This limit is 1. In the next example, I have an indeterminate difference. As I take x's closer and closer to 0 from the right side, the first fraction gets closer and closer to infinity. The second fraction also gets closer and closer to infinity because tangent of x gets closer and closer to 0 from the right, which means 1 over numbers closer and closer to 0 from the right is closer and closer to infinity. This is of the form infinity minus infinity, an indeterminate form. To rewrite it in a form something divided by something, I will find a common denominator, and I will get the limit as x goes to 0 from the right side. I will multiply this fraction at the top and at the bottom by tangent of x, and I will take this fraction and I will multiply top and the bottom by x squared. And I will get, in the numerator, tangent of x minus x squared, and in the denominator, I will get x squared tangent of x. As x goes to 0 now, in the numerator, I have 0 minus 0. In the denominator, I will get 0 times 0, which is also 0. This is of the form 0 divided by 0, which allows me to use L'Hopital's rule. When I do that, I have to take derivatives now, and I get the limit as x goes to 0 from the right side of, in the numerator, the derivative of tangent is secant squared of x. The derivative of negative x squared is negative 2x. In the denominator, I have a multiplication of two functions. I must apply the product rule here. The derivative of x squared is 2x. I multiply it by the second function, tangent of x. And I add to it the first function, x squared, multiplied by the derivative of the second function. The derivative of tangent was secant squared of x. Let's analyze what happens to these expressions as x goes to 0. Negative 2x is definitely getting closer and closer to 0. Secant squared of x is the same thing as 1 over cosine squared of x. And cosine, as x goes to 0, gets closer and closer to 1. So this is the same thing as 1 over 1 squared, which is 1. This expression gets closer and closer to 1. In the denominator, 2x gets closer and closer to 0. And tangent of x also gets closer and closer to 0. What's more, both of these terms get closer and closer to 0 from the right side. In the second term in the denominator, x squared gets closer and closer to 0 from the right, and we said that secant squared gets closer and closer to 1. Which tells me that in the numerator, I have numbers 1 minus 0, so that gives me 1 in the numerator. In the denominator, I will have 0 plus, and here 0 times 1 is 0, so I have 0 in the denominator. So this is of the form 1 divided by 0 plus, numbers that get closer and closer to 0 from the right side. And we know that 1 divided by 0 plus gives us infinity. We get numbers that are larger and larger. This limit is infinity.